Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good morning everybody. Welcome to another program of Let's Collaborate. And this time we are fortunate to have the Center for Communication Systems and Network or CCSN from Universiti Tunku Abdul Rahman or UTAR. So this program is co-organized between the IEEE ComSoc VTS Malaysia, as well as the Center of Communication Systems and Networks, CCSN, from UTAR. So we have three speakers for our Let's Collaborate program today. And as you know, this is our third series of the Let's Collaborate program. We hope that this program can actually introduce some of the research centers and the researchers in Malaysia who are working on something related to communications, and so that we can collaborate with each other, perhaps in terms of working into new projects or looking for new grants, etc. So with us today, we have three speakers. So the first one will be Prof. Lim Eng Hock. So welcome, Prof. Lim.
Thanks, Prof. Yusof.
Okay, so Prof. Lim is actually the center chairman. And then we also have Dr. or IRTS Dr. Tham Luen. Hi, Dr. Tham.
Hi, Prof. Yusuf.
Who is the center member. And the third speaker, we're going to have Dr. Ying Loong. Right? He's also the center member for CCSN. Welcome, Dr. Lee.
Hi. Thank you, Prof. Yusuf.
Okay, so I think we're going to start with Prof. Lim first. Let me just introduce Prof. Lim. Prof. Lim was born in Malaysia. He received Bachelor of Science degree in Electrical Engineering from National Taiwan Ocean University in 1997. Master of Engineering degree in Electrical and Electronics Engineering from Nanyang Technological University, NTU, in 2000. And PhD degree in Electronics Engineering from City University of Hong Kong in 2007. So he's currently a professor with UTAR. He was also the founding chair of the IEEE Malaysia Council on RFID. He served as an associate editor of the IEEE Transaction on Antennas and Propagation from 2013 to 2016. And he is now serving as the associate editor of the IEEE Journal of Radio Frequency Identification. Since April 2021, he has been a distinguished lecturer of the IEEE Council on RFID, and he is a fellow of the ASEAN Academy of Engineering and Technology. His current research interests include RFID antennas, reflect arrays, transmit arrays, and multifunctional antennas. So without wasting any more time, I hand it over to you, Prof. Lim. So the session is yours.
Yeah, thanks, Prof. Yusof, for the nice introduction. Okay, first of all, let me share my screen. Can you see my screen, Prof. Yusof?
Not yet. Okay. Can. Hold on.
Okay, thanks.
Yeah. All right.
Okay, thanks all my friends and also colleagues from either academics or industry. Okay, I am the chairperson of the Center for Communication Systems and Networks at UTAR. And of course, right before I start with my research, the report on my research, I would like to go through the research activities of my center first. So basically, I think there is a very broad range of research in my center. First of all, we have a lot of research activities on applied electromagnetics and sensors, and we have researchers who are very active in microwave remote sensing. For example, we have Professor Yu, our president, and Prof. Chong Moon Kwan. They are very active in microwave remote sensing. And we are also very active in the RFID antenna research. This is mainly led by me. And actually, right, in this antenna design, every year, right, we have published about 10 IEEE transactions paper every year in antenna design. And of course, right, we are also very active in sensors and actuator. And the researcher who is leading this is Dr. Chi Pei Song. And of course, on top of this radio frequency, we are also active in this broadband network technologies and also management. For example, we have a researcher who is very active in network management and also telecommunication, as well as green communication. I think Dr. Tham Luen, who is having his sharing later, will be talking on a bit more on this green communication. And we will have we have also a researcher who are active in wire and wireless interconnecting system. For example, we have research activities in a research project in mobile management and resource allocation, as well as network security and also encryption. And of course, we also have research projects in communication theory and application, such as those in digital signal processing and radar and navigational system. So here shows you some of our research activities. I think yearly, right, we are able to secure about more than 500,000 of Malaysian ringgit of grants. And of course, right, I think last year, right, we had more. We had almost 2 million of grant, including, right, international grants. And this is of course, right, if you are interested to work with us, you are welcome to approach any of us anytime. Okay, so now, without further ado, I move on to the introduction of my research. Okay, so my part here, this part will take about, I believe that, right, about 30 minutes. Actually, right, I have about 97 slides here, but I do not intend, right, to go through all. I will just tell you the essence of my research activities. So here, I will go through with you the research and development of RFID at UTAR. And of course, right, my name is Lim Eng Hock, right? I'm currently a professor at UTAR. Here, I have also put my email and also handphone number here. In case you want to find my group member or my center for any collaboration, you are welcome to contact me anytime. So, okay, now let me go through the outline of my presentation today. I will introduce to you RFID. I believe that, right, because this talk is mainly delivered to the IEEE ComSoc and also VTS. Not all of you are in the field of antenna design. And of course, right, I will introduce to you what are the application of RFID in the second part. And I will go through with you some of the RFID techniques. And later on, this one, the ometer RFID antennas, this is mainly my research area. We have published about 30 IEEE transactions, 30 journal papers in this in the IEEE transactions on antenna propagation, just on this ometer RFID antennas alone. And of course, right, I will go through with you some of the miniaturization techniques for RFID tags. So, okay, let me start with the introduction of RFID. So, and of course, right, RFID, the name as it defined, right, it is one type of identification technology. And of course, right, more precisely, it's one type of auto identification technology. On top of the RFID, actually, right, there are a number of identification technologies that you are familiar with, right? For example, your MySejahtera, actually, right, your MySejahtera is a second dimensional barcode, and you are using it every day, right? Not only that, right, let's say if you are taking up a merchant item in the supermarket, surely you will see either the one-dimensional barcode or the two-dimensional barcode. All this actually, right, they are carrying the identification of that particular item, right? That's the reason why you are calling it to be auto identification technology. On top of that, right, moving to the biometric system, you have those, for example, you face feature, of course, right, is also very unique, right? You can make use of the face feature for identification. And not only that, right, actually, iris also carries unique information that you can make use of it as identification. Not only that, right, your smart card, and also, right, surely it's not only your smart card, right? Even your passport, it carries an RFID, right? And actually, right, this is an auto identification system. Of course, right? I think for optical people, you should have known this one, the optical character recognition. This is one of the most popular identification technique in optical engineering. Of course, right? For my research topic, I will be focusing on the RFID. I think RFID, right? It comes by your daily life every day, right? You will touch, see RFID every day. Just that, right? You know or don't know, right? Okay, now let us start with some of the essential concepts of the RFID. So, in principle, right, RFID is a technology, right, that is applying electromagnetic fields and wave to track commercial items, right? So, this RFID, right, in order to do that, of course, you just look at it, right? You must have a tag and a reader. So the advantage of this is that you can see that, right? Even for those, I think this one for some factory solution, automation solution, right? They are applying this RFID to track commercial items, right? Over here. And not only that, right? You can see that, right? This kind of RFID reader is very commonly seen. And I think all of the stores, they sure have this one, right? To track those items automatically. I think very obvious, the main advantage of the RFID is simple, right? It can track and read the item without direct line of sight. It means that, right, even though you don't see the item, you don't see the tag, and you can still track it. So, and of course, right, I understand that none of you are in this field, right? So first of all, let me go through some pictures with you, right? Because pictures are the easiest means to understand this RFID, right? So I think, right, the first category of RFID, they are working at low frequency. You can see that, right, for this low frequency, it is in the range of about 120 and 130 kilohertz, right? In terms of kilohertz. To work in this frequency range, basically, the principal working mechanism is through inductive coupling. So that if you open up such a tag, right, you will see a lot of wire coil, And of course, right, there are a lot of limitation of this low frequency RFID system. So that, right, there's a reason why, right, people are moving the frequency up to high frequency. And of course, right, this high frequency, although the name is a high frequency, right, but actually, right, the frequency is not so high. The frequency is 13.56 megahertz. And the most common application for this high frequency tags are like what? For example, your control access card. Actually, right, if you have a chance of, let's say, right, dismantling the card, you will see such still is working based on electromagnetic coupling, right? You will see such a coil, right? But now the coil is working at 13.56 megahertz. So now, and of course, right, this high frequency, it has some advantages. And of course, right, it also has some disadvantages, which I will discuss later, right? And the third category is the ultra high frequency. You can see that right over here. I think this type of tag, you also have seen it in many places. For example, your My RFID, right, system, for the tolling system, right, you should have seen such tag that is placed on your car, on the head screen of your car, right, and so on. Right. For this tag, it's working at about 860 megahertz to 960 megahertz. You can see that, right? The frequency have shifted up from 13.56 to about 800 to 900 megahertz, right? So for this category of tags, actually, right, it is working based on the electromagnetic principle. It means that, right, the signal will be sent using electromagnetic wave, right? So that because of that, the tag that you are seeing here is designed based on the antenna design theorem. So, okay, now we go through some of the comparison, right, between the RFID and also the barcode. Firstly, right, the RFID, right, you can place it anywhere, of course, right? And most importantly, right, your reader, it doesn't need to be in the direct contact with or direct line of sight with the tag. And even your tag is embedded or hidden somewhere else, right? It can read it. It can read it, right? And of course, right, not only that, RFID text, right, you can use the text in a harsh environment, such as outdoors, chemicals, in a very moisture and high temperature environments. Not only that, right, I think if you go to the supermarket, you have seen, right, okay, you have taken some commercial item. When you are checking out, or they have to place the reader to the optical reader, right, to read the barcode. But of course, right, if you cannot see, let's say, right, if you're removing the barcode further away, right, in that case, you won't be able to read it, right? But for RFID, right, actually, right, depending on the technology, it can be read, right, from maybe 20 cm up to, right, 100, 200, 300 feet away, right? And of course, right, most of the RFID text are reprogrammable, right? You can always reuse the text. And barcode, right, once a barcode is printed, right, you cannot change it anymore, right? If you don't want it, you just throw it away, right? And that's it. Okay, now here shows you the working principle of RFID. So the RFID, it consists of two important parts. The first one, of course, right, is the tag, right? The tag that you are placing it, you are tagging it, right, on a certain item, right? The other end, you have a reader, right, to read the information from the tag, and the signal that is acquired from the antenna, it will be sent to a reader module, right? So after getting the information, the signal from the reader module, then it will be sent to a computer, right? Since it can be connected to computer, very simple. So you can also connect your computer to let's say to internet. So that, right, you can process the data, the information by using IoT and also some of the clouds, right? You can even store the information on the cloud. So here shows you, right, some of the application of the RFID technology, right? Needless to say, right, you can use it for payment, product checking, identification, logistics, asset management, and access control, and so on, right? So before I start, first of all, right, we need to classify the text, right, according to the functions or the application that it can be used for, right? So these are text, right? The RFID text, it can be attached or placed, right, on almost everything, right? For example, on pallets, cases, vehicle, and luggage, people, and even electronics, right? So depending on what it can do, right? So that you can classify the RFID text into 5 categories. So for the class 1, it is class 0 and class 1, right? It is for read-only passive text. And if you are getting embedding, right, some additional functionality to the text, right, it becomes class 2. Right, and of course, right, you can also put in a battery, right, so that, right, the read range can be further, so that, right, it can carry, let's say, for example, right, even more function. So for such a tag, it is a semi-passive tag. And of course, right, you can also make it to become active, right? It can carry a mini battery, so that, right, it can perform even broadband peer-to-peer communication, right? Such a passive tag, it is classified as class 4 and so on, right? Okay, so here shows you some of the advantages of the RFID. So very obvious, the RFID technology, it can access or read data without visual access. And of course, right, you can also access data for moving objects, and you can read data from either a read range or from a few centimeter up to 100 meter or 200 meter, right, depending on the technology. And also, right, since you have a reader and you can place your data on the cloud, right, you can also apply some encryption feature to secure the data, right? Most importantly, right, it is able to access or to have automated read of multiple text at any time, right? This is an obvious advantage if you are comparing it with this barcode, right? Barcode at any one time, you can only read one item or one tag, right? Or one barcode. But for this tag, you can read maybe 300, 400 texts at any one read, right? Okay, now, so here shows you some of the regulated frequency for performing this RFID technology, right? So first of all, the one that you have seen just now, firstly, right, it was working at about 120 to 140, right, kilohertz at the LF. And we're moving up, this is the HF. And moving up further, it becomes the UHF. So, of course, right, when you want to design RFID, for sure, right, you need to know where you are using this RFID tag, right? So that, first of all, right, the regulated band is different, right, depending on which country you are in, right? In Malaysia, right, actually, the regulated frequency, the regulated spectrum for this RFID is from 919 to 923 megahertz. Okay, and we move on, right? So here shows you some of the tags that you can see in the market, right? So for those low frequency which are working at 120 to 140 kilohertz, right? For this kind of tag, it's not easily affected, right, by water or metal, right? But for such a tag, right, usually, right, the data rate is very low because the frequency itself is very low, right? And the read range is also very short. Usually, right, it's within 1 cm, 2 cm. And when moving up to this high frequency, right, and of course, right, no matter for the HF or the RF, right, both of them are less affected by water and metal. And of course, right, because you are moving up the frequency, surely, right, the data rate will increase. Again, right, this HF is still working based on the magnetic coupling, right? Because of that, right, the read range is still shorter, right? Usually, right, it's in between maybe 5 cm up to about 20 cm, right? It's still short, but it's longer than the LF, right? LF is usually, right, below 3 cm or below 2 cm. So when you're moving up to the ultra high frequency in this microwave range, right? So that, right, the read range can be much longer, right? Usually, right, it can go beyond 3 meter, 10 meter, 20 meter. And if you're using active technology, right, it can even go up to 100 meter, 200 meter. And of course, right, such a tag, right, is easy to produce, to manufacture. And cost is usually very low, right? Because you are moving up the frequency. So that, right, the data rate becomes also much higher. But as you know, right, in this frequency range, you are applying electromagnetic wave to send the energy. And this EM wave, right, it can be absorbed by water and it will be reflected by metal, right? There's a reason why, right? So that, right, when you are designing a tag in the UHF range, right, you have to be very careful on the application, right? Either if you have water or metal nearby, right? And of course, right, not only that, right, when you are placing the tags near to each other, right, they could have interference and coupling effect, right? Of course, right, you need to take care of this one during the design stage. Okay, now here shows you some of the common application of the RFID, right? So you are using this RFID in the manufacturing and processing, right? For sure, supply chain, retail, security, and also tracking, right? So actually, I have a lot of example here, but I won't go through all, right? I will just go through some of them. So I think in Malaysia, right, needless to say, all of you might have seen this before, right? My RFID. Actually, right, my RFID is a passive tag, right? You can either put the tag on the headlight, and also, right, you can put it, right? Some of you, right, can put it on your windscreen, right? So that, right, not only that, right, I think for a lot of cases, you can, most of your car, right, you also have a smart tag. You have a machine, right, which is you are placing, right, a cut into it, right? Actually, the cut itself, right, it is an inductive coil. It is a near field technology, right? It is the low frequency tag, low LF tag. But when you are putting it into the machine actually, right, is working at a much higher frequency. it has a battery to activate up all the electronic circuit, right? And because of that, right, the read range can be much further, right? It can read, let's say, from 100 meter, 200 meter, right, without any problem. Right, but here, right, I just put a note here, right? Actually, in Malaysia, right, we are using such a tag, right? But you will find out, right? You have to why you need to put it on the headlight here, because why? The read range is shorter, right? Because why? Because you are using a dipole. Surely, right, the read range is short, right? And of course, right, you can improve it by many other ways, right? So on top of that, right, you can also implement the tag on the car, right? You can either use dipole, put it on the top, right, so that it can be read in all directions, right? You see that, right? This is a very beautiful pattern, right? Like a donut, right? Actually, this is the radiation of the antenna on the top of your vehicle. Not only that, right, you can also use your patch, right? You can also put your patch at somewhere else on your vehicle, so that, right, it can achieve a much further read range. So again, right, these are some of the tolling technologies, right? They are applying the RFID. Okay, not only that, right, this if you have stayed at somewhere medical center before, right? You have seen this one. Actually, right, this tag is called Lim Eng tag, and this is the hospital blanket, right? It can track where, how many times this blanket has been used, right? And also not only that, right, all the kids' surgical gown and also the hospital bed sheet, right? All of them are carrying, right, this Lim Eng tag, right? Actually, we are designing, right, this Lim Eng tag together with the MDT innovation, right? And this tag is designed, right, based on using all those medical materials, right? And it can stand up to 1.5 to even 3 Tesla under the MRI setting. You can see it, right? Even you put the tag inside the MRI, right? The IC won't die, the tag won't die, right? It can survive. Right, and of course, right over here, right, you can see, right, it's my student here. And of course, right, we are the first group in the world, right, to apply the flexible substrate to design the metal mountable RFID, right? And we have a far pattern, a WIPO pattern. And of course, right, not only that, right, UTAR here, right, we are also applying the AI technology, artificial intelligence technology, right, as well as the design of experiments technology to design RFID tags, right? And we have a pattern on that also. And of course, right, because the tag itself is flexible, right, you can place it in even on a human body. And here shows you another solution on the smart rack, right? Actually, right, at UTAR here, we are working with industry, right? Actually, right, quite a lot of our funds, right, come from industry. For example, no matter locally or internationally, right, we are working with the industry to deliver solutions to the industry. And actually, right, this is one of the example. And we are working with MDT to deliver, right, the solution on the smart rack as well, right? You can see that, right? Each of the bottle, the cover of the bottle, right, is carrying a tag, right? So all the no matter is medicines or chemicals, all of them will be tracked automatically, right? And even you will know, right? You don't need to go and check, right? You will know which chemical is going expire, for example, right? Okay, here also shows you another example on the smart rack solution, right? You can see here, you have 2 readers here. And all this, right, actually, this is being used, is used by the hospital. You could have some of those medical items, right? All will be tracked automatically. So not only that, right, this one is used by the Ying Loong. I'm not sure, right? Actually, you click on here, right? This is actually a link to the Ying Loong website, right? And actually in Japan, right, the human labor is very expensive, right? So there's a reason why, right, they are embedding, they are implementing, right, this kind of solution into all those merchant items here. So that, right, it means that, right, okay, you can take, let's say, for example, you can take a sock or a cloth from here, and you can just check out. Even at the counter of checking out, there's nobody over there, right? And because you can just because each of the item is already embedded with a tag antenna, right? Not only that, right? This is you can apply the RFID, right, for the smart library solution, right? So when you are taking a book from here, you can check it out at the counter easily, right? There is it doesn't need anybody to man the counter. And of course, right, this one is the smart grocery solution, which is implemented by using RFID text, right? You can see that, right? Okay, you put all your items, each of your items is carrying, right, a tag. And not only that, right, even you can see that, right, this bottle drink, right, they are carrying this tag as well, right? But if you see that, right, this bottle drink, right, you have to make your tag to become something like a flag here, right? This is very troublesome. Actually, right, my research is actually solving this problem. My research, right, is proposing a lot of planar antennas for this metallic objects. So again, right, you can use this RFID in the inventory and production monitoring and so on, right? And of course, right, you can also use it for tracking people and use it for ticketing, right? I think if you travel to KL, you are traveling, right, on the Rapid KL ILT, surely you have seen this kind of ticket. Now, let me go through the second part of this one. This will be introducing on the RFID architecture, right? And of course, over here, right, I do not intend to go deep into the electronics because, right, I think, right, not all of you are in this field, right? So, as I have said just now, right, your RFID system, it consists of the RFID tag. And also over here, right, this is the RFID antenna and also the RF antenna and the reader system. These are the reader system. And here shows you the interfaces that the system is has involved, right? So obviously here, this is for the text, and you can have multiple text, right? So over here, this is the architecture of the reader, and also the system. You can see that, right? At the end here, you can transfer your data to cloud IoT and so on, right? And of course, right, there are many types of RFID reader, right? So the function of the reader is simple. It's to powering up the tag remotely, right? If your tag is passive. And of course, right, it is to establish the bidirectional data link with the tag, talking to the tag, and also, right, after acquiring the data, right, also your reader is communicating, right, with the network server, right? So you can see that over here, you have many types of reader. For example, the agile reader, fixed server, and also smart reader, right? These are all in the market. This shows you some of the readers they have seen, right? And of course, right, this is showing you how the reader is implemented, right? Basically, right, you have a power supply, you have a multiple module here, right? You have a module that's working at 915 and this 13.56 megahertz and so on, right? So here shows you some of the available readers in the market. You could have some passive readers and also active readers, right? And of course, right, depending on the cost of implementation, right, it can be made into a read-only, also read and write, right, the text. So here shows you, right, the architecture of the tag block diagram. Obviously, right, if you are applying an active tag, it will have a battery power supply. If the tag itself is passive, right, actually, right, this block doesn't exist, right? Then, right, it will harvest energy from the reader, right, to power up all the subsequent blocks here. So here shows you, right, some of the capability or some of the passive text, right? So that, right, of course, right, for passive text, it's less expensive, it's cheaper, and of course, right, it can also have some memory to store the information. Here shows you, right, some of the passive text, and of course, right, you can see that, right, for each of the tag, right, actually, right, it carries a chip. And the chip, right, is actually very tiny, right? To put the chip onto the antenna, right, actually, right, you need to have a special soldering system. Okay, here shows you, right, the features of some of the active text, right? And of course, right, because you are using a battery, right, the memory can be much higher, right? So here shows you some of the active tags, right? For example, right, your smart tag of your tolling system in Malaysia, right? This is an active tag, right? Of course, the card itself, right, is working at low frequency, as I say, right? Maybe about 130 or 230, right? It can be even 13.56 to 13.56 megahertz. So it is communicating with your tag reader, right, through either LF or HF, right? After that, right, then the signal will be transmitted out from the tag, right, using maybe, right, 2.4 or even a higher frequency, right? Okay, so now here, actually, right, my group is working, right, on the ohmmeter UHF tag antenna, right? So as I said just now, right, why you need to have special design technology for this ohmmeter tag? The reason is very simple. So that, right, when you are placing a tag antenna on a meter, right, it will generate this image current, right? And this image current is actually, right, in the opposite direction with the direction of the current, the image current, right? And the current on your antenna, right, they are actually in the different direction. Because of that, right, they are cancelling out each other. Because of that, the rising efficiency will deteriorate, right, significantly, right? So because of that, right, when you are designing an ohmmeter tag antenna, it would need a special techniques. For example, right, these are some of the antenna structure that you can use, right, to design this metal mountable RFID tag antennas, right? The most famous one is the microstrip patch antenna, right? But I think in commercial use, right, nobody is using such just a simple microstrip patch antenna, right? Because very simple, the size is very huge. And not only that, right, you can also use, for example, grounded dipole, PFA, antennas with EBG and AMC, right, to implement the solution. And you can have even some antenna with high permittivity spacer. So, and of course, right, so here shows you some of the requirements that are needed for a tag antenna, right? First of all, it must be easy to manufacture. This is very important, right? So that, right, the cost can be low. And of course, right, because you are placing the tag on a certain commercial item, right, or certain merchant item, so that, right, the profile, it has to be very low. And of course, right, the size, it has to be very, very small, light in weight. And of course, right, on top of these requirements, you also need it to achieve a much further read distance and so on, right? So as I say, right, because your antenna, it can be sensitive to the surroundings, right? For example, right, if you are placing it on metal, on water, right, the read range can be compromised, right? Because of that, right, you are trying to make your antenna as insensitive to the backing object as possible. So here shows you, right, some of the design trade-off that you need to take care of when you are designing a tag, right? Firstly, right, is the antenna size. For sure, right, when the antenna size is larger, right, the read range can be further. But unfortunately, right, you can make the size too huge. Otherwise, right, actually, right, a big antenna, right, it has no commercial use anyway, right? But if you are shrinking down the antenna size, surely the read distance will be compromised, right? So you have to work in between the antenna size and read distance, right, in order to optimize the antenna performance. And finally, right, you also have to take care of the material costs, right? A tag, right, can be the cost, right, it has to be very, very low. A simple tag, right, can be maybe 7 cents, 8 cents kind of selling price, right? Okay, here shows you some of the measurement system for the antenna, for the UHF tag antenna, right? I just show you the picture, right? Because, okay, basically you have a tag antenna and also a reader here, right? The picture is shown here. Actually, right, we have such a system at UTAR here, right? At UTAR here, we have the design system, the design software, and also the design system, and also the measurement system for all types of RFID antennas. And the system that is being employed here is the Voventic performance system, right? And this is actually a commercial system, right? So I think this mathematics I won't go through, right? But because, okay, now we come to this miniaturization technique, right? Actually, there are many ways to cut down the size of a tech antenna, right? You can see that over here we are applying, right, the folding and serration method, right? Okay, you are putting the antenna on a PET or polyimide, right? And you can fold it so that, right, the size can be shorter. Right. Okay. These are some of the results. So we are measuring it inside the performance measurement system. So here is the measure read range, and we have simulated this surface current. Right. So you can see that, right, we have actually tested it, right, on different dielectrics as well as the metal objects, right, the metallic objects, and we compare it with the commercial items. So here shows you another technique is minder, right? You are mindering the slot to miniaturize the text size, right? You can see here the text size is actually quite small, right? You are putting it right side by side to this $0.25. So here shows you some of the analysis, right? Which I do not want to go through all. You can see that, right? This antenna, right, is actually quite competitive. If you are placing it, right, you are comparing it with those commercial antennas. And the third one is the folding arms. This is the excitation loop, right? Actually, right, you can fold the arm. This is actually the dipole antenna. After folding it, and the size can be miniaturized and so on, right? And of course, right, over here, showing you some of the analysis, right, which I do not intend to go through all. Right, and here you can see that, right, we have measured the impedance, and also, right, we can measure the read performance inside the performance system. So over the years, right, we have designed, right, a lot of antennas. You can see, right, we have also published, right, a lot of transition papers, right, in the past 5 years in the IEEE transitions on antenna and propagation. So over here, you can see that, right, designing a ohmmeter tech antenna, right, it involves making strenuous trade-off in between the antenna size, read distance, and also the material cost, right? Obviously, right, longer read distance is obtainable by sacrificing the antenna size. Smaller antenna size is obtainable by sacrificing the read distance, right? So you have to strike a balance, right, in between the two. Right, so that, right, and of course, right, the main challenge is that what you have to learn, right, how to design a small antenna with effective tuning mechanism to bring down the frequency, right, to the regulated frequency range, right, or the XXO to 960 megahertz. At the same time, right, you have to maintain a good read distance. So obviously, right, you can't have both, right? You cannot have a small footprint and far read distance at the same time. You have to put a balance. You have to find a balance between the two, right? So over here, right, we also would like to draw some non-technical conclusion, right? We appreciate CREST Foundation, right? CREST Fund, right, for sponsoring our project, right? Actually, it has helped to build up the RFID, right, and the ecosystem in Malaysia successfully. Actually, we are now, right, working with a lot of these companies to help the SMEs in Malaysia. And also, right, not only we are very active working with industry, right, we are also very active in academic research. Actually, right, in the past 5 years, our research group, right, should be publishing the most, right, in the IEEE transactions on antenna and propagation, right? I think we have accumulated more than 30 papers in the IEEE transactions. And you can find this information, right, from this link here. So, okay, so I think these are all I have, right? I am a bit of overdue, right? Maybe about 4 to 5 minutes, right? So I think this is what I have for my presentation today. Thank you very much.
My mic was off. Thank you, Prof. Lim. I think it's very interesting to see some of the work in RFID. There's quite a lot of things to learn from you. Perhaps maybe in the future we can invite you to give a specific talk on the RFID, especially on the antennas, on the antenna design, and perhaps on how to publish in some of these IEEE journals as well, right? Okay, so next we have IR TS Dr. Tham Luen, one of the center members for CCSN. I'll just read a little bit about Dr. Tham. He received his Bachelor of Engineering First Class Honours in Telecommunication Engineering and PhD degree in Wireless Communication from Universiti Malaya in 2010 and 2015 respectively. After PhD graduation, he joined Mimos Berhad for 1 year as a senior researcher in the Wireless Innovation Department. He is currently an assistant professor with the Department of Electrical and Electronics Engineering, Universiti Tunku Abdul Rahman, UTAR. His research interests include IoT, machine learning, deep reinforcement learning, and video communication. He is also a professional engineer in electronics, registered with the Board of Engineers Malaysia and Professional Technologies, also in electronics, registered with Malaysia Board of Technologies or MBOT. So without any further ado, let's welcome Dr. Tham.
Hi, Prof. Yusuf. Thanks for the introduction. So, Prof. Yusuf, can see my screen?
Okay, Ken, I've already shared your screen, so
All
you
right.
can
Okay.
present.
Shall I proceed? All right. Okay, I'll start the presentation. Give me a minute. All right, so good morning, everyone. So first of all, so thanks, Prof. Yusuf for the nice introduction, and also thanks, Prof. Lim for the nice opening. So good morning, everyone. My name is Tham, and I'm an assistant professor from Universiti Tunku Abdul Rahman and a member of Research Center for Communication System and Networks. So first and foremost, I would like to thank the IEEE Malaysia, ComSoc, and BDS for inviting me as a speaker. So the talk today will focus on our ongoing ASEAN IBO project activities, which aims to develop a context-away disaster mitigation using mobile edge computing and wireless mesh network. So I'm the project leader for this ASEAN IBO project. So basically, ASEAN IBO stands for the ICT Virtual Organizations of ASEAN Institute and NICT. So it is a global alliance of ICT R&D activities between the institute and university in the ASEAN regions and Japan. So the mission of ASEAN IBO is to seek and identify strategic ICT research areas in the ASEAN regions and promote the collaborative projects among them. Right. Okay. So basically, I will just give a short overview, okay, about this project, and my presentations will have roughly 10 to 11 pages, right? So let's begin. So the ASEAN IBO project basically started in last year April and will be expected to end in next year March. So the duration is exactly 2 years. And the budget we obtain is 80,000 USD dollar, which is split into the year 1 and year 2. And the projects, as I mentioned, actually it involves multiple parties. So from here, we have the National Institute of Information and Communications Technology, NICT, then the Ready Affiliates Japan, then the BHN, the Basic Human Needs Association, all from Japan. Next, we have the collaborator of from Mimos Berhad from Malaysia, and then we have the University of Computers Studies, Yangon from Myanmar. So last but not least, we also have the collaborator from Pachuan Institute of Technology from Thailand. So yeah, so this is about the project background. Okay, so we know that basically natural disaster occurs frequently around the world. So Internet of Things sensors such as a videos camera can actually detect such event and try to track the number of victims. So in existing IoT framework, okay, so video streams normally are generated from distributed IoT devices, which are transmitted to the remote cloud for via the wired connections for further analysis. So doing this actually will incur several issues. So the first one will be the massive deployment efforts and cost. So for example, while cities such as London and Beijing have deployed advanced network of video surveillance, so the vast majority of them are wired into the physical infrastructure, which may incur the massive deployment costs and efforts. Then the next one will be the data transfer over limited bandwidth and high latency in communications networks. So just imagine if we try to process all the video stream at a remote cloud. So doing so actually will consume a huge amount of bandwidth and high communications latency. So this is highly impractical for developing critical situational awareness over the disaster zone when everything is when we talk about the golden hours in the disaster situations. And then the third issue would be the high redundancy in disaster related content. So when a large scale disaster strikes, disaster contents generated by each IoT monitoring nodes may be redundant. So all this actually may leads to the network bottleneck. So this prompts us to try to filter those redundant content before actually disseminating them to the nearby emergency response unit. And the last one will be the lack of holistic rescue operations guidance. So existing navigation system is likely to malfunctioning due to the damage of communication infrastructure and routes during the disaster. So all this actually may render the rescue operations struggling. Yeah. So these are the four issues that we aim to resolve in this ASEAN IBO project. So with this in mind, our project goals are divided into three parts. The first one will be the H-level disaster detection. The second one will be the mesh network database synchronization. And the third one will be the evacuations route strategy optimization. So let's come into the first one, the H-level disaster detection. So H-level means that the video analytics are performed at the H node instead of sending them to a cloud server for further analytics. So even doing so, we know that this is still challenging since we know that the deep learning models always relies on the expensive GPU power in order to perform some inferencing. So in goal number one, we aim to develop a lightweight deep learning module that actually can detect the number of victims and the disaster types simultaneously. And then when disaster strikes, so it's likely that infrastructure like base stations will be destroyed. So goal number two, resolve this issue by performing the mesh network database synchronization. So more specifically, critical information is stored in the data, installed in the distributed database of a network called NerveNet, and those information will be disseminated to the emergency response unit by using the wireless mesh networking. So the last goal is about the evacuations route strategy optimization. So with our proposed solution, the optimum rescues itinerary is established based on the real-time disaster detections outputs. Yep. So let's come to the goal number one, the H levels disaster detection. So recent advances in deep learning and computer vision has transformed surveillance into an important application for smart disaster monitoring system. Based on the detected number of victims and the activities of the disaster, then emergency response unit can actually dispatch manpower more efficiently, which could save more lives. So, however, most of the existing disaster detection methods fall into the class of single task learning. That means they can either detect victim or classify disaster. So, in contrast, our solution actually can perform the aforementioned tasks simultaneously by using one framework called multitask learning, which is part of the deep learning framework. So we have just submitted our work to a conference. So this is one of the screenshots that actually we extracted from the paper. Yeah. So as shown in this figure, so the solution will actually identify this as an earthquake and also detects the number of the persons within these scenes simultaneously. So basically, if according to the normal task, okay, if we want to detect the number of the person and also classify disaster, we may need to deploy multiple convolutional neural network. So doing so actually will increase the computational complexity and the overall cost of the system. So as mentioned, so we go for the joint disaster classification and victim detection using the multitask learning. So the next one will be the goal number 2. So mesh network database synchronization. The key technology used in this goal number 2 is the NERVNet, which stands for Never Die Network. So as the name implies, okay, it is a network that is very robust. Okay, so that's the reason we choose this. Okay, so basically it has 3 main features to offer for. So the first one will be about the network. So NERVNet uses mesh topology, which provides the resiliency to each network. So specifically, all these mesh topology can be established using various communication technology like Wi-Fi, Ethernet, and even the LoRa. Then the second one will be about the simplicity. So the system is simple to deploy and includes useful services such as an inbuilt database synchronization mechanism. So recently, NERVNet has introduced the Docker version, which allows the researcher and also developer to easily install the NERVNet in various distribution of the Linux system. And the last one will be about the reliability. So the NERVNet actually is a proprietary technology which is developed by the Japan's NICT. So it is built to be very reliable and stable. So specifically in NERVNet, each NERVNet node is independent of the other, and it is tolerant to link disconnections and system failure because of each mesh structure and fast route switching on layer 2. So this makes it very suitable for the disaster response network. Yeah. So this figure illustrate the mechanism of the mesh network database synchronization. Okay. So let's focus on the top left corner. Okay. So at this part, basically the telemetrics data is captured by some sensor nodes. So in our case, it will be the video cameras that is equipped with our customized deep learning models to capture all the necessary data. So by using the multiple Raspberry Pi, so all these icon is the Raspberry Pi as the NERVNet nodes. So telemetrics data is synchronized to other member nodes using the NERVNet feature called Hershey element. Okay. On top of that, multiple gateway is used to enable the resilient internet connectivity. So because we assume that when a large scale disaster strike, so maybe some of the gateway will be destroyed. So how to actually keep disseminating these informations to nearby existing party? Okay, so one of the straightforward approach would be we adopt the multiple gateway, right, in order to increase the resiliency. So all these synchronized telemetrics data can provide alerts and insight for emergency response. Also, the regional evacuations notice can be triggered by local authorities via NERVNet. So we also develop a cloud monitoring dashboard, okay, which is used for the nationwide monitoring. So for this purpose, 2 protocols are used, namely the HTTP and also the MQTT. So the MQTT actually stands for the message queuing telemetry transport. And in fact, it is one of the most popular communication protocol that used for the IoT scenario. So HTTP will be used for the to receive the media files like the image, whereas the MQTT will receive the network status and also the textual information. So in our preliminary study, we actually try to use the MQTT to transfer the images. But what we found out that in order to do so, we actually need to encode this kind of images into the base64 format. So doing so actually it will increase the encoding time and also it will increase the size. So based on this reason, that's why we split them into 2. HTTP for the image transfer, whereas MQTT for the textual information transfer. So the textual information, for some example, is once the video camera detect it as an earthquake and the number of victims, so all this will be formed in the part of the textual information, and then we can rely on the MQTT's endpoints to do the necessary transfer. Yeah, to do the necessary transfer. So based on all these cloud monitoring dashboard, then we actually can have the goal of that multiple NerveNet regional disaster response network, so which can be connected to the cloud server. So in our preliminary test bed, we assume one gateway, okay, and two base stations nodes. Okay, so these are the two base stations, and we assume one NerveNet gateway. So there are two figures. So the left-hand side figure shows the network architecture, whereas the right-hand side shows the actual implementation. So let's take a look at the left-hand side first. Okay, so as you can see from this figure, okay, the wireless link of the NerveNet are established using the Ethernet remote bridge feature of the NerveNet. So you can see that basically we form a triangular link, okay, among these three Raspberry Pi. So to establish this kind of ERB link, the Ethernet remote bridge, okay, so one node must have a wireless interface configured as the AP. So let's say now focus on this Raspberry Pi. So you can see that the black one indicates that it is operating as the access point. And then in order to form the triangular, which is the mesh link, then basically another base station, the base station number one, need to configure one of each wireless interface as the client. Okay, so the same mechanism repeat for the base station 1 and base station 2, and the same repeats for the base station 2 and the gateway in order to form the triangular. So let's say if anything that is received under this one, then thanks to the NerveNet Hershey daemon, all the data actually will be synchronized among these three so-called NerveNet base station X nodes. And let's focus on the right hand side. So how do we implement is for this preliminary study, we actually use 3 units of Raspberry Pi 3 model B+, and 3 units of the TP-Link AC 1300 Archer T4U high gain wireless USB adapter. So another things to take note is you can actually see that for different types of the wireless channel, we purposely separate them. So the yellow color indicates the channel 11 of the wireless of the Wi-Fi. Then green color indicates the channel 6, and the last one, the blue color, indicates the channel 1. So this is to avoid the wireless interference among themselves. So the next one will be the front end design. Okay, so as we mentioned, we actually need to develop a cloud-based monitoring dashboard. Okay, so this is what we call it as a nerve dashboard. So as you can see from this figure, okay, so you can see that the status active. So status active, victim count, and the disaster, all these falls into the textual information, which will be transferred using the MQTT, because MQTT is suitable to transfer all these lightweight data. And besides that, the camera footage actually will show some selected picture. So of course, we wouldn't transmit all the images, simply directly transmit all the images to the cloud-based monitoring dashboard. So only when some disaster happen, and only when some number of victims is detected, we only will trigger the image transfer. Because like what we mentioned just now, simply transmit all these images back to the cloud actually will increase the network bottlenecks. Yeah. So yeah, so this one just shows the front end design of our NerveNet dashboard. Okay, which we call it as NerveDash. And the last one is about our goal number 3, okay, the evacuations route strategy optimization. So yeah, as shown in this figure, so on the left hand side, we have some emergency cases, for example, some accidents, crime, fires, explosion, and disaster. So how to actually initiate some immediate rescue operations, okay, is depends to some closest service station. And then there might be some scenario that during certain disaster, the infrastructure or some routes actually may be damaged. So how to actually design and also develop routes, specific routes informations for all the necessary emergency response units to reach the destination. So it will be the key of this goal number 3. Okay, so our work actually has been presented at the 2021 IEEE 10th Global Conference on Consumer Electronics. So I think we just presented it last week. Okay, last week. So yeah, basically the our objective in this paper has 3 parts. The first one is to develop an optimal routes identification system for emergency event based on the geographic information system by combining with web services. Then the second one will be to examine the closed emergency service and support the optimal routes between the rescue services and the incident place by using the geospatial data and display the route result with the details direction. And last but not least, the third objective of this goal, this paper is to modify and improve the original Dijkstra algorithms in order to apply the complex and large routes network by reducing the memory and time consumption. So all this is motivated by the fact that we only have the maybe some golden hours in order for the ERU to react. So definitely how to actually construct and apply very fast routes will be one of the key points in this ASEAN IBO project. So these are the summary, okay, of what we are doing. Okay, so in terms of the ongoing activities, okay, so we actually still have 4 more, okay, or maybe more activities to do. All right. So the first one will be actually we are still studying the NerveNet mesh network with the LoRa. So the reason why we opt for this one is we know that basically Wi-Fi the distance is quite limited. So how to actually efficiently monitor the disaster in the very last field. So we actually need to rely on the very long distance. So LoRa will be one of the key and will be extensively used in this ASEAN IBO project. So we are still studying it. And the second one will be to optimize the disaster detections model. So just now, as I mentioned already, we already developed a multi-task deep learning model. But this one can only perform fairly quick and good in a very high GPU mode. In a very high GPU mode. So imagine if we want to deploy a very large scale of monitoring IoT monitoring nodes, where the monitoring node can only have some low computational power. So we actually need to optimize them further to become a lightweight model. So one of the directions that we have been looking is to use the Intel OpenVINO in order to optimize this kind of model, so that they can actually be readily deployed in the real situations with the appropriate frame per second and with some decent high accuracy. And the third one will be about the NerveNet integration with the disaster detection. So right now, we are still studying all 3 goals separately. And of course, our final goal is actually to do the merging between the, so the first merging operation will be focused on the NerveNet integration with the disaster detection. So, so of course, this one will follow after we optimize it to a lightweight model. So once the lightweight deep learning model is implemented inside the Raspberry Pi, then the Raspberry Pi, the same Raspberry Pi actually we also have to NerveNet in order to do the mesh networking and also the database synchronization. And of course, the last integrations step will be focusing on integration with the evacuations routes strategy. So based on the real-time detected outputs, like the number of the victims and also the types of the disaster. So basically the evacuation route strategy can actually use this real-time input to be part of the optimized routes evacuations and sent to the necessary and relevant emergency response unit for the in order to initiate the rescue mission, right? So yeah, so I think that's all about my sharing. okay, of our ongoing ASEAN IPO project. Thank you.
Okay, thank you, Dr. Tham. That is a quick summary of what you have been doing.
Yes.
So far, if there is any questions, I think they can contact you directly.
Right.
So far, we don't see any questions yet in the chat.
Right.
But definitely, I think they will be asking if they have any questions later on. They can actually email or visit your websites to get to know more about your projects
Right.
and perhaps have some collaboration with your team later. Okay, thank you, Dr. Tham. And then
Right.
now we will move on to the third speaker. We have Dr. Ying Loong, right? And then actually it's written as Ying Loong Lee, but I think his surname is Lee. A little bit about Dr. Lee. He received his Bachelor of Engineering degree in Electronics, majoring in Telecommunication, and PhD degree from Multimedia University in 2012 and 2017, respectively. He was a visiting researcher at National Chiao Tung University in Taiwan under the 2015 NCTU Elite Internship Program in 2015 and at Guangzhou University for Nationalities under the ASEAN Talented Young Scientist Guangzhou program in 2019. He is currently an assistant professor with the Lee Kong Chian Faculty of Engineering and Science, UTAR, and he is currently serving as a member of the IEEE VTS Ad Hoc Committee for AI in Wireless Communication. His current research interests include wireless communication for 5G and also 6G. So the floor is yours, Dr. Lee.
Okay, thank you, Prof. Yusuf. Yeah, thank you for having me. So let me share my screen. Yeah, let me try to put full screen. Prof. Yusuf, can you see my full screen?
Yes. It's on full screen now.
Okay, thank you. Okay. Thank you, everyone. Thank you for the introduction. So my surname is Lee. Yeah, I actually graduated from Multimedia University. Actually, is where Prof. Yusuf is now at the university at which Prof. Yusuf is working at. So yeah, so I actually am an assistant professor with the Lee Kong Chian Faculty of Engineering and Science, Utah. So maybe I go straight to my research activities. So there are four main research areas that I'm actually working on. The first one is the radio access network slicing. The second one is artificial intelligence, AI, for resource management. The next one is the 6G, which is currently getting very popular. And the last one is the UAV, Unmanned Aerial Vehicle Assisted Communications. So let me talk about my first research area. So probably I introduce what is network slicing. So actually, network slicing is a technology for 5G. When we say we want to slice a network, basically we want to create multiple virtual networks, which are virtualized over the physical network infrastructure. So the purpose can be for provisioning of a particular service. In 5G, we have three types of services. One is the enhanced mobile broadband. Second is the ultra reliability and low latency communications. And the third one is the massive machine type communications. So it can be either of these services. It can also be for provisioning of services by a particular operator, such as the fixed wireless access or hybrid access between the DSL, the copper-based network, or any other fixed type networks, right? So there are basically two technologies that are involved when we performing network slicing. One is called the network function virtualization, and the other is called the software-defined networking, right? So in general, there are two types of network slicing. One is called the core network slicing, slicing at the core network, and we have radio access network slicing, meaning slicing at a radio access network. So when we say end-to-end network slicing, meaning both core and radio access network slicings are also involved. My research area mainly focuses on the radio access network slicing. More precisely is on how to allocate resources among network slices. So when we say resource allocation, is about the allocation of radio access network resources. So since 5G networks have incorporated new technologies such as edge computing, cloud computing, so allocation of radio access network resources not only involve the radio channels or transmission power allocation, but also involve computational resources at the edge or at the cloud, storage resources at the edge and the cloud as well. Okay, so these are the problems or research directions that I am working on. So radio access network slicing not only involve the allocation of radio access network resources, it's also about selection of network settings. So you can see in this figure, the two things that I haven't talked about is the network function placement and the scalable OFDM numerology, right? In 5G, there's a new frame structure. We call it scalable OFDM numerology, meaning the bandwidth of each radio channel can be scalable according to a certain parameter we call numerology parameter. So depends on the different service types, we can set different numerology parameter. For example, if we are dealing with ultra reliability, low latency communications, so we should use larger bandwidth or larger subcarrier spacing, okay, for the radio channels, okay, which they call resource blocks in 5G. Okay, so the other one is the network function placement. So because we for network slicing, network function virtualization is involved, meaning some network functions can be virtualized, okay, softwareized. So these network functions can be placed at the edge or at the cloud, depending on the types of service. If it's a latency critical services, it is more important to put these network functions at the edge so that the distance between this base station to the user, when we have data transmission, it can be shorter. I mean, the data processing can be done at the edge, closer to the user, so the transmission, after the network function process the data, that data can be sent to the user more quickly, right? If the services is not latency critical, so most of the network or data processing functions can be located at the cloud, okay? And with this flexible placement of network functions, right, we can actually optimize the network performance. So it's also under the radio access network slicing. All right. So you can see in this figure there are different slices, right? It's just an abstract visualization of network slices. So you can see this is the cloud. Let's say slice 1. You can see there's a cloud, and then there are many nodes, right? So CP is actually the control plane, NRT is the non-real-time functions, RT is the real-time functions, RF is the radio frequency function. So you can see there are different functions located at the cloud and sometimes at the edge, depending on the service types, right? So under this project, I have, under this research area, I have 2 projects which I secured. One is a university funded by university, and the other is funded by the FRGS. So actually, I am collaborating with Prof. TC Chua from Multimedia University and Prof. Jonathan Lu from the University of West London in the United Kingdom. Right. So we have some publications under this research area. One of the prominent ones is actually the paper that I published with Prof. TC Chua, which is to the IEEE Communications magazine, one of the top telecommunications journals in the area of telecommunications. Basically, here we talk about the application of radio access network slicing in fixed mobile convergence. So fixed mobile convergence is actually a network paradigm where fixed networks like DSL or fixed wireless access combined with the mobile networks like 4G and 5G. So for those who are interested with this application, you can refer to this publication. And if you are interested to work on this area with me and also Prof. Desitra, you can always contact me anytime. All right. So next is artificial intelligence for resource management in 5G networks. So this is my another area. Basically, is to apply AI to solve some resource management problems in 5G networks. So here, the resource management, basically, I study the cell activation, meaning how to turn off or on base stations in order to save powers. Sometimes some base stations, they don't have users to provide services. So maybe we can turn it off to save power. Next is the user association. Mainly is to determine which user to connect to which base station. Sometimes it's based on the channel condition, but we also need to base on the quality of service requirements, data rate requirements, latency requirements. So this is another problem. And I also work on the resource allocation, sub-channel, and power allocation, right, which is the more conventional one in the area of resource management. So I have worked with a university in China, Guangxi University for Nationalities. Basically, I work with Prof. Chin, and we work on this project under a program called China ASEAN Talented Young Scientist Program. So this program actually funds my visit to this university, Guangxi University for Nationalities, for 6 months. So this program can provide a monthly allowance of renminbi, China renminbi, 12,500 monthly allowance, right? And they have a travel budget of 25,000 China renminbi for me to go to participate in conferences, forum, seminars, and so on. Any technical events, right? So for those who would like to explore this program, you can check out the website here. This is the main website. So maybe I slightly introduce what I have done under this program, right? So under this program, I have the opportunity to participate in various fora. All right. So the first forum that I participated is in the 7th Forum on China ASEAN Technology Transfer and Collaborative Innovation. So in this forum, I witnessed the collaborative technology transfer exchange and agreement between ASEAN universities and China, right? Well, and on the same event, actually is the on the same day with the other forum, which is the ASEAN Plus 3 Young Scientist Innovation Forum, right? So I have the opportunity to speak at this forum, ASEAN Plus 3 Young Scientist Forum. So to give an opinion on how a collaboration between Malaysia and China can be advanced, right? So actually, in this forum, we have other speakers from Indonesia, Vietnam, Myanmar, and other ASEAN countries. So to give an opinion on how collaboration between ASEAN and China can be advanced. All right. So these are some of the photos, right, that I have taken. And under this program, as I mentioned, we can participate in technical events. We can perform technical visits to some industries. So this is some of the industries that I have visited, mostly in Guangzhou, China. So I visited various ICT companies, and then they showcase a lot of ICT products, which I found very amazing. So these are the some of the industrial parks that I visited. And also it allows me to participate in conferences, regardless of whether I have any research papers to be presented in the conference. The travel budget does not restrict me if I just attend the conference. So it's one of the advantages of this program for me. So I have participated in one of the major conferences in China in ICT, CNCC. So it's a very grand conference with thousands of people, right? So I attend this conference, and also I have a paper to presented in another conference, APSIPA AST 2019. Actually, I attend this and presented at this conference together with Dr. Tham. Yeah, so all these are under the China ASEAN Talent Young Scientist Program. Yep. So under this research area, so I back to my this research area. So I not only collaborated with the Prof Chin from China under the ASEAN Talented Young Scientist Program. I also work with Prof TC Chua. In fact, he is my PhD supervisor, from Multimedia University, and another collaborator from Oman, Al Shakia University, Dr. Ayman. Who was previously with MMU as well. So now he's actually moved to Oman. So I worked with him, and we managed to publish a good journal paper in IEEE Wireless Communication Letters. Yeah, so this is the current result that I have under this research area. So my next area is on the 6G massive radio access networks. So maybe a brief introduction of what is about massive access networks. So we can foresee that in the future, there are many devices that can connect to the internet, mobile devices. We can have a lot of applications such as the autonomous driving, IoT devices, intelligent factory, smart manufacturing, manned aerial vehicles, and people have envisioned that we could have undersea communications connected to the mobile networks. Right. So in this area, I'm just started. So at this stage, I'm trying to explore possible enabling technologies for 6G massive access. So I have worked with various universities as well to explore the enabling technologies here. Of course, one of the possible technologies is network slicing, which I have mentioned before. Yeah. So I will talk a bit about what are the possible enabling technologies later. Okay, so under this research area, I actually work with 3 collaborators. And one of the collaborators, Dr. Alison Sim from Technical University of Darmstadt from Germany. So we have applied together from the German Research Foundation, DFG, to get the initiation of collaboration grant. So the name of the project is 6G Multi-Radio Access Network Technologies Communication Systems. Right? So it is a grant to establish collaboration between the TU Darmstadt and UTAR. So this grant allows us to have a mutual visit to university in Germany and also in UTAR. So for now, we have invited Dr. Alison Sim come over to UTAR to give a talk on 6G. So the next activity that I will be performing is to visit their university and have a knowledge exchange, right? So under this research area, so we have publication, not only with Dr. Alison Sim, but also with professor from Taiwan, Prof Wang, who is in fact is an IEEE fellow. So we work together with him, and we publish a journal paper exploring several enabling technologies for 6G. So one of them is network slicing, and the other one is what we call the hybrid precoding. All right. So actually, this technology is proposed by Dr. Alison Sim, which is as an enabling technology for 6G. And the other one is energy harvesting technologies. Although energy harvesting technologies are not new, but recently it has gained a lot of attention because with a massive access definitely the energy or power consumption will be very substantial, and we need a very powerful energy harvesting technologies to achieve that, right? And or energy efficient technologies to allow massive access. So one of the energy harvesting technologies are like intelligent meta surfaces, right? Beamforming technologies for energy harvesting. We also have something called rectanna. Okay, it's a type of antenna that is good for energy harvesting. So actually, this I think Prof. Lim is more expert on this rectanna technology. Yeah. So and also we proposed that quantum computing is another possible energy efficient signal processing techniques, right, for the massive access. Okay, so for details about the 6G technologies, interested readers can refer to this publication. Yeah. Okay, so lastly, I have worked on, recently started this research, UAV assisted communications. Basically, I focus on UAV mounted base stations communications. So there are a lot of works on this area, but I focus on load balancing, how to balance the UAV base station load, right? So that they are not overloaded or some are not underloaded, right? To have a better load distribution or resource utilization distribution among the UAV base stations. So this is another collaboration with the Dr. Alison Sim and with the a professor from China, Prof. Chin. Yeah. So recently we have submitted a conference paper, and which is currently under review. Yep. So this all these research areas are basically simulation research and basically involving development of algorithms, right? So this summarize all my research works. Yeah. So that's all from me. Thank you.
Okay, thank you, Dr. Lee. I think it's very interesting to see some of the so many collaborations that you're having with various parts of the world. Perhaps if anyone would like to get more details of how Dr. Lee actually started all these collaborations. But yeah, as mentioned by Dr. Lee, he is actually an alumni of Multimedia University. He has been working from degree up to PhD. He did
Yes.
with Multimedia University. So thank you, Dr. Lee, and I think that will be the end of our session today. Thank you to all the speakers, Prof. Lim, Dr. Tham, and also Dr. Lee Loong, for the insightful of the research areas and also the research topics that Center for Communication Systems and Network are working on from UTAR. So if you do have any questions, or if so far I don't see any questions in the chat, but I think they may be able to contact all three speakers through their the email addresses and also the websites they have shared. Okay, so that's all for today. If you have not signed in your attendance yet, please sign in the link that is already shared in the Facebook chat, or you can look in the description in YouTube. If you are watching on YouTube, then you can just sign in YouTube. We have 5 free memberships for IEEE ComSoc or VTS, whichever that you prefer, for 5 free lucky attendees. Okay, so that's all for today. Thank you everyone for joining. Hope to see you in our future events. Thank you so much.